Så vi kommer laga mat. Det var inte kul för det tog mig.
Okay, good morning.
Totalt 6 timmar att göra.
So let us continue the lesson. So applications of derivative. In the book they have just written applications. But of course we are in the chapter for derivatives. That's application of derivative. And if I want to be more specific, I really call it optimization. I will give it the title of optimization. So optimization is probably clear. So what you have in your hand, you want to make the most benefit out of it. Yes. So you want to optimize. So if you want to earn money, you want to make it as big as possible. If you want to lose money, you want to make it as low as possible. So optimization could be maximizing or minimizing. So that's a good word for it, optimizing. Yes? So let me start with a simple problem. Assume that it's a practical problem. So assume that you want to make a garden for yourself, for example. I'm just showing you the top view. So this is the wall, and then you want to make a rectangular garden for it by fencing some part of the land around it, okay? So that is your fence. So that is the wall. You don't need to fence on the wall, of course. So you have to fence 3 sides of that rectangle and make your garden here, yes? That's the top view. But you have some limitations. For example, for some reason, you have some specific length of the fence. For example, so let us consider that you have 50 meters of this fence, yes? So the total length of the fence that you have is 50 meters, and you want to make a garden for yourself. Usually you prefer to have a garden as large as possible. Yes. So you want to have a garden. You have 50 meters of fence. You don't have extra material in your hand. Of course, if you can increase this one, this is clear that you can cover bigger land. Yes. But the point is that you have only 50 meters available. You can make your garden, I don't know, thin and long, or you can make it a little bit fatter, something like that, so that the whole perimeter that you use is 50 meters of fence. The point is that if you do it, this area will be covered. If you do the black one, this area will be covered. If you do it in this way, this area will be covered. And usually, this is a good motive. Do it in a way that you can cover the maximum area. Yes? Assume that you really want to do that. So that's a practical problem. You see, you have 50 meters of fence. You want to optimize something. Here, optimize means maximize. And what is that quantity that we want to maximize? Is the area. Is that clear? Okay. Now, this I just want you to see that is a real life problem. You really, if you want to do it. Okay, and then how we connect this problem into the derivatives and things like that. So because when I want to talk about the derivative, I have to have a function. Because if I want to differentiate, to use derivative, I have to have a function to differentiate. So this means that you need to set up a function first, which is your target function, and that is the area. Okay, so I don't know. Let me just clean the extra. Let me clean and then do it just with one of them. Don't want to confuse you. So assume that this is your garden. We don't know the length. So if you don't mind, let us call it X. We don't know the width. So if you don't mind, let me call it Y. And my target is A, the area. It's a good name. Instead of saying function f of x, it is better call it A because it denotes area. And then try to write a function for your area. It's extremely simple in this problem, yes? Because if I consider this x, this y, then area is x dot y, yes? So that's the area. But the point is that how many variables are involved here, you see? There are 2 variables involved, yes? One of them is x, the other one is y. And if I want to differentiate, I should have only one single variable in my problem, yes? Either x or y, it doesn't matter, but it should be one single variable. So it means that, sorry, I need, my voice happened something to. Okay, so it means that I have to replace y for x or x for y. This is where, I'm sorry, this is where that you can use this extra piece of information. How can I use that? The total length is 50. So what is the meaning? It means that the total length that you see is supposed to be 50. Yes?
X plus y is equal to 50.
X plus y?
Yeah.
No.
Not x. Just look.
2y plus x.
Okay.
Yes, because I have two y's, but
Yeah.
one x. Yes, that's correct. So 2x, sorry, x plus 2y should be 50 meters. And then what can I do? For example, I can calculate y in terms of x or x in terms of y. Because I don't want to make you confused a little bit, if you don't mind, let me just do this cancellation, okay? I myself prefer to cancel x because I do not have any coefficients. But let us, for the time being, try to get rid of y. This becomes 50 minus x. And then I want to have y, so I divide by 2, so it becomes 25 minus 1/2 x. And what I do, I put it back here. Then I have my function as usual. What do I mean as usual? It means that it's a function of one single variable. Here, this is x. And instead of y, I put this expression. And then you see that everything is in terms of x. So, if you don't mind, let me call it a function of x. Yes or no?
Yeah.
Okay. But now, there are some practical limitations for x. It's a practical problem. So, what is the minimum possible value for x? So, I can make it thinner and longer. So, it means that x, hopefully you agree with me, is not 0, but it cannot be negative either. Yes, x is the length, cannot be negative. So, and for x equals to 0, it doesn't make sense, yes? So x should be a positive number, but there is a upper bound to it. Can it go up to infinity?
No.
No. What is the maximum threshold of that x? Yes?
Less than 50.
X less than 50, yes. X cannot be longer than 50. Yes? So this is the new problem. That's it. The rest of it becomes the lesson for the previous two sessions. In the previous two sessions, if you remember, a function was given, an interval was also given, and you were supposed to find its maximum and minimum. The only difference now is that you have a word problem. You need to read it and understand it. Try to set up your function and your interval yourself. As soon as you do this, then this becomes the previous problem. Now you can forget about everything, just concentrate about your function and your interval. Yes?
Is it a coincidence that x is less than 50 and 50 is equal to the length, total length?
No, that's exactly because of the problem.
So,
because, for example, if you want to, imagine some extreme cases. So you can make it smaller, but you make it longer because you want to use all the fence. Yes. And then it means, but you cannot make it negative because negative doesn't make sense and 0 doesn't make sense. If you want to make it 0, it means that you have one single line. There is no garden. Yes. So it means that there is an upper bound for it. An upper bound, you cannot make it very, very long because you have only 50 meters. You can make it very thin in this direction and long, but this cannot go beyond 50 meters. Yes? That's not a coincidence. I mean that if I change this number to 100, then the upper limit becomes 100. Yes? Is that right? Yeah. Okay. Now you can, when you reach to this level, then you can completely forget about everything and solve the previous lesson. Okay, so it means that what are the steps? If you don't mind, okay, I have to differentiate that, but you haven't studied the product rule. You will study it in the math board. So, but you know how to differentiate this. What should I do? You had this in one of your exams. If I give you a function of like this and I ask you to differentiate it, what's the first step to do? Yes, Rocco?
First, the multiplier.
Yeah, in this case, you have to multiply, yes? So what I do, so I will multiply that. This becomes 25x minus 1 over 2x squared. Okay? And now I differentiate it. It becomes 25. And then I will get minus, I have 1/2 here. 2 goes down. 2 will cancel this 1/2. And I am left with x. Yes? This is the first step. Do you remember what was the second step? The second step is to equate the derivative equal to 2, 0. And then find the answers if they are acceptable. Is this 25 acceptable in this setup? Yes, because my interval is from 0 to 25, and this is in that interval. But in principle, do you remember what was the next step? The next step was to calculate the function for that value as well as the endpoints. Yes? So, but of course, this problem is, so here, when I write A25, I have to calculate it. Do you remember? In principle, I should also calculate A0 and A50. But if max and mean occurs at one of these, I have to exclude them because they are not included. Yes? But these kind of optimization problems, you really don't need to bother about these scenarios. What happens even from the geometrical setup? What will happen if x is 0? What would be the area? Imagine that I am making x small.
0.
Because I want to keep this 50, I have to make it taller and narrower. But if x really becomes 0, what would be the area?
0.
0. Okay, so it is clear that I really don't need to bother about this boundary in this practical problem. And what happens if I make x 50? If I want to make x 50, then I have to make y smaller and smaller, so y becomes 0. And then I will have a garden which is just one line. The area is again 0. If you don't believe, you can put them here and calculate. If I put 0 here, it becomes 0. If I put 50 here, this one becomes 0, but the total product also becomes 0. But then I have to calculate A25 as well, so it means that I have to put 25 here. So this becomes 25, multiply 25 minus 1/2 of 25, 25 over 2 is left, so it becomes 625 over 2. Which, if you want, in this case, let us write it in decimal points, it doesn't matter. So 312.5. Okay. But because there is another difference here, because in ordinary mathematics, functions are pure numbers, but here this function denotes area. So you need to consider the units. So here, A25 is this area units. That's also one difference. But of course, don't get confused. For the time being, I want to find the maximum of A. But it is clear the maximum is the largest value among these numbers, and that is exactly this number. Okay? And if I am, if it occurs at these endpoints, which it don't, then you need to exclude them because they are not included. But anyway, that is the maximum area. So this means that this person, if you have this 50 meters, at most you can cover a garden of this area, not more. So it means that if this is not appropriate for you, you have to spend money to buy more. But if that is okay for you, that's the maximum value. But from practical point of view, usually the maximum value is important for us. But I don't know, the most important question is how to achieve that. So how should I achieve that? This tells you what to do. What should I choose for x to achieve that? I choose 25. Yes? So it means that this person understands how to do it to reach to that maximum value. That person should take x to be 25. If x is 25, you put it here and you calculate y. So what is y?
12.5.
So yes. So x. Let me write the question in this way. So the maximum area is 312.5 area units, and it is achieved, or it is attained, when x is 25 meters and y is 12.5 meters. Yes? So this is a nice problem. It was a simple problem, but a practical problem. It is tangible in real life, yes? And if you want to maximize the garden, to cover the garden, it tells you how to do it. It tells you that the length should be 25 and the width should be chosen 12.5, which was not that easy to predict from the beginning, yes? That's a good problem. So it tells you how to do it to achieve the maximum possible value. Yes? That's an optimization problem. Yes, I am using the most out of my money. Yes, my friends. Yeah. Okay, so these questions could be hard. Not because of the calculations, because these calculations are completely similar to the previous lesson. The hard part is that how can I read the words in the problem and set up my function and my interval? Somehow the hard problems might involve geometry as well. Okay, is that clear? So let me give you, there's a good problem in the book. Let us go for it, okay? So let me start. So the question, if I understand it correctly, is that you want to make a cylinder with the maximum volume. For example, you have cardboards, you want to cut them in a way and make them cylinder so that the volume of the cylinder is the maximum possible value. So it means that the total area, but let me tell you in this way. So this is the constraint in the problem. So let's consider just a cylinder like this. Okay, and the radius is, for example, r, the height is h, and then you want to maximize the volume of this, but there is one constraint. Of course, if you have infinitely big source, you can make it bigger and bigger, the volume becomes big. But if you have some limitations, for example, you want to keep the total area fixed, and that number is given. The total area is 150 pi area units. I'm just, this is the problem exactly in the book. I'm just using, it's a good example. I want you to understand that. The total area, so if you want, I can emphasize the total area. Let me see if they have considered the total area. Yes. The total area is 150 area units. But how many cylinders you can imagine? You can imagine thinner and longer cylinders so that they are consumed, they have the 150 pi area units. I can make them shorter but fatter, still consuming the same area. Yes. But among all these cylinders, I want to choose the one with maximum volume. Okay? The question in the book asks you about the maximum volume, but we can also ask about the dimensions for that cylinder, which will give us the maximum volume. Okay, so this is my advice. If you want to solve this problem, you have formula sheet in front of you. What is my target function here? What I'm supposed to maximize or minimize? It is given in the problem, the volume. So you take a formula sheet and go and read the volume of a cylinder if you don't have it in mind. If you go there, you see that the formula is this: pi r squared h. The area of the base multiplied by the height. That is the volume of a cylinder. Then you see there is a problem. How many, but be careful. R and H are more natural variables to use in geometry rather than X. I can write X squared Y, but it is natural to call it R and H because they are radius and height. Yes, so remember, this is one thing that you need to remember. So, how many variables are you involved in the formula for the target function? 2 variables, one R, one H. Why they are variable? Because when I can make it thinner and higher, so it means that I am changing R and H, or the other way around. So R and H are both variables. Then you would need to understand, you can only solve problems with one variable. Okay? So it means that I have 2 variables, I have to get rid of one of them. And then how? You need to go back and see what is given to you in the problem. In the problem, there is a constraint always given to you, and that is the total area is supposed to be this particular number. That is, I don't know, I don't remember in the formula sheet, do you have the total area for the cylinder or not? Might be not. So then you need to visualize it a little bit to be able to find that. Okay, can you tell me how can I calculate the total area of a cylinder? Let everyone thinks about it.
I just want to ask a different question.
Yes?
Do you mean, when you say area, do you mean volume or because you're using...
No, area.
Area.
Area means, I don't know how to say.
That's 2 dimensions, right? And volume is 3 dimensions.
Yes.
Okay.
Yes, but of course, this is a solid object embedded in 3 dimensions, but you can still talk about, exactly like cube. If you have a cube, and then each surface is a 2-dimensional object, and you can talk about the area of each surface.
Okay.
And if I ask you what is the area of the cube, in that case it is simple. You just calculate the area of each one of these squares and multiply it by 6 because there are 6 surfaces. Yes?
Yes.
But in this case, that's also the same thing. It means that I need to consider the area of top, the area of the bottom, and of course the area, the circumference area. I don't remember the English word for that, but the area of that this object. Yes. So for example, if this is my bottle, I want to calculate this area. Yes. Okay. So that if I show it with A is given to be 150 pi. So, but for the area, I think these 2 are simple because each one of them are squares. They are the same size. What is the area of the circle? If you have forgotten, you can see it in the formula sheet. But I really recommend you to memorize these famous ones. So pi r squared is the area of one of these. I have 2 of them, one on the top, the other on the bottom. So this means that 2 pi r squared. But the hard part, I don't know. I don't think this is in the formula sheet. So what is the area? I don't remember. I think it's circumference area or something, or side area. I think side area is a better word. So what is the side area of a cylinder? Yes, Abdul Manan, but you have to defend it, not just the formula.
The height and the diameter, or how to say that, pi times 2r.
Yes. Why is that?
It's because the circle down there is also the, I don't know exactly how to say it, but it's basically, yeah, I don't know.
Okay, anyone can defend this? So yes, yes. 2 pi r times height.
Yeah.
So why?
That's correct, because we looked at in geometry, like
No, assume that you are using your memory. Forget about the memory. Why is that correct? Whenever I want you to use your memory, you don't use it. Whenever I don't want you to use it, you use it. Yes? Yes.
So, by first of all, we can calculate the circumference of the circle by doing what was it?
No, but what is your strategy? Why we actually bother about calculating the circumference of one of those circles?
If we know the circumference, like all of it, and then we times if we multiply it with the height, we know the area of.
Why?
Well, because
that's a round object.
Yeah.
Why, if you do that, it will give you the area? The reason is that if I cut the cylinder and open it up, it becomes a rectangle. That's the reason for that, yes? So that I cut my cylinder from here, and then I open it up. Then it becomes a rectangle. Agree? Yes. So hopefully this is not a good picture, but this will be what? If I open it up, this becomes height. Okay? But this side, this circumference of the circle will open up and it becomes from here to here. Do you agree? Yes. But that length is the circumference of that circle. And there is a formula for the circumference, as Abdul Manan mentioned, pi times diameter. So you can say 2 pi r. And then because this is a rectangle, everyone knows about the area. You need to multiply the height and the width together, so the area becomes 2 pi r h. And that's the reason. But of course, in the exam, you really don't need to write the reason. If you know that, you can use it. Okay? So this area consists of 3 parts: top, bottom, and the side. Top and bottom both have the same because that's a factor of 2 you see here. And then I have to add that one. So it is 2 pi r h equals to 150 pi area units. Don't lose the logic. What was the logic? I needed this equation in the first place because I want to write this in terms of one variable, not 2 variables. Yes? But let us do some simplifications. Every time you can do simplifications, don't hesitate. So I see that 2 pi, and 2 pi are common. So I just divide everything by 2 pi to get rid of these extra things. So this becomes r squared. This becomes r times h. This becomes 75. I divided everything by 2 pi. I wanted to make it simpler. But now look, I have 2 options. Either eliminate r in favor of h or h in favor of r. Yes? Which one is practically better? So let me tell you something. For example, a very, very simple example. If I have 2 variables, so x plus 2y equals to 5. I can either write x equals to 5 minus 2y. So I am eliminating x in favor of y. Or I can write y equals to, I move it to the other side. And then because this is 2y, I have to divide by 2. I myself prefer to do the first option here. If I do the second one, I have to deal with fractions, which is harder. So I myself prefer to do this one, even though I deviated this in my first example, because I don't want to get confused between x and y. So here, which one is more practical for me? Do you think that I need to... So my question is that, should I make x alone or y alone? Yes. Here, should I make r alone or h alone? Which one? R.
They are combined.
No, they are combined, but I can make them one of them alone. Yes?
I would eliminate h.
Yes, so you mean that you make h alone?
Yeah.
Because you are right, because let me make h alone first. I move r squared to the other side. And then I divide by r. Yes, or you want, if it doesn't matter, you can write 75 over r minus r. Yes? I am done with elimination. But assume that, let me change my color because that's not what I mean. Assume that you want to do the other way around. What do I have to do? This is a quadratic equation in terms of r. So it means that you need to write it in this way in your head. R squared plus h times r, and then you move 75 to the other side equals to 0. If you really insist to do it in that way, you have to solve it as a quadratic equation. For example, ABC formula, minus b becomes minus h, plus or minus square root of this one squared, minus 4 times that one is 300. And then divided by 2. Okay? Now r is alone. Do you prefer this one or that one to work with?
H.
Hopefully this one. There are two obstacles here. First of all, you have a square root sign, which can be nasty in its own. And then I have two options. I have to care about two options here. So this is why, even though technically both of them are possible, but I really want you to understand, before doing the elimination, don't go for this one, because then you will say that Babak, the question, the time in the exam was not enough. Because Babak have designed the question in a way that you're supposed to do this, not that one. If you choose this one, that's up to you. Yes?
Where did you get 75 from?
I divide everything by 2 pi.
Okay.
So it's 150 divided by 2 is 75, and pi and pi are gone. Yes? So do you understand what I mean? So these technicalities you need to improve. Don't fall into this trap to work with this, even though mathematically it is possible to work with that. Now everything is clear. So what was the target of doing this? Do you remember what was the goal? The goal is to eliminate one of these variables. Because of the algebra of the problem, it was much easier to eliminate h. So this means that when I found h, I will go and put it back here. Then what I get, I finally get my target function in one variable. So this becomes v equals to pi r squared. Instead of h, I put 75 over r minus r. And now I can safely call it v, or if I want to emphasize on its function behavior, I can call it a function of r. Yes, is that right or not? Okay. And then I can even simplify it more. Yes, because you know that you don't know the product rule. Even if you know the product rule, I know the product rule, but I still prefer to multiply because differentiation would be simpler for me. But the problem is not finished yet. I multiply r squared in 1r and 1r cancel, so it becomes 75r. But r squared times r becomes r cubed. So that is by function. But the problem is not finished because I need also an what do I need more to maximize and minimize a function? Because I am not dealing with local maximum and min. I am dealing with absolute maximum and mean. Yeah?
Parameters.
No? Function and interval. I need two things, functions and intervals. Yes? This is my function. What is my variable? My variable is r. Technically, I need to tell myself what are r. What is the lowest possible value for r? What is the largest possible value for r? What is the interval on which r varies? So can you tell me? The lower bound is clear because r is the length of the radius, so it cannot be negative. And even 0 is not a good choice. Do you agree with me? When you say r is equal to 0, you have just one straight line, infinitely long line. Yes. So, but is there any upper bound for r? It's a little bit hard. I agree, but so can you imagine what is the highest value for r? It's a little bit tricky. I don't know why they have mentioned it here because I just considered this, but we can understand that. Look here at h. Can h be negative?
No.
H cannot be negative because that's also height. So this means that this will impose some limitations on how big r can be. For example, can r be 10? Because
No.
if this is 10, 75 minus 100 is negative. So this means that because I want to have h positive, I have also a limitation how big r can be. So what is the maximum possible value for r is that r squared should be less than 75. because other than that, h becomes negative, which is meaningless. So then h should be less than the square root of 25. Yes? Sorry, square root of 75. Something like that. But I just want to tell you, if you don't find these numbers for the optimization problems, they are not that actually important. Why they are not important? Because here, usually the minimum values and maximum, the optimized values does not occur at the endpoints. They occur somewhere in between the integral. So even if you just follow this, you will at the end get the same answer, the zero answer, or whatever. So you can imagine that if r is very small, yes, if r is very small, then the volume becomes zero, even though this is very large, but then the volume gets close to zero. But you want to maximize the volume, so zero is probably not a good choice. Okay. Now, from now on, then you can forget about the geometry totally and just do the problem in the previous sessions. So you just differentiate this function. But I hope that you agree now, r is playing the role of the variable x. Yes? Here, pi is a constant. I don't bother here. I differentiate this. Remember, r is x in your problem. So the derivative of x becomes 1. The derivative of r becomes 1 now. So this becomes 75. And the other one is minus, can you tell me? 3r squared. And then you have to put this equal to 0. This gives me pi 75 minus 3r squared is 0. Then this means that 3r squared is 75. This means that r squared is 25. And this means that r is either plus or minus 5. But of course, minus 5 is not acceptable because radius cannot be negative. So this means that r is positive, or you can say that because r is in this interval, I ignore the negative value, and then I get 5. And then r is a radius, so let me write length unit here. So by the way, be careful about writing the units when you are doing practical problems. So r is 5 length units. In this question, yes?
How did you come to the conclusion of the square root of 75? I'm sorry.
So here I told you that, for example, can r be 100? Can r be 10? Because, for example, if I put 10 here, this becomes 100. 75 minus 100 is negative. H is the height, cannot be negative. So it means 75 is the maximum value that r squared can reach. R squared should be less than 75, because if r squared is greater than 75, it gives rise to a negative value for the height, which is nonsense. Yes. Yeah. But in this case, you really don't need to worry about, because you can convince yourself. You see, if I put 0, in principle, this is not done yet. What I have to do, according to the previous lesson, I have to calculate v of 0. I have to calculate v of square root of 75. I have to calculate v at 5 as well and choose the maximum value. Yes? This is just a candidate. But if this is very simple, you see, as you predicted, if I put 0 in the function, this becomes 0. And if I put the square root of 75 here, again, it becomes 0. You can convince yourself of that. And if I put 5 here, let me calculate. So this becomes 5, 75 times 5, minus 5 to the 3. So how much is that? 350, yes? Am I right? This is 375 minus 25. Yes, I think it's right. So this becomes 350 pi, but you have to write volume units. Volume units, if you want to be very strict, volume units. But you are looking for the maximum value. So, of course, as I told you, you really don't need to be worried about these boundary points, because this is the 0, and definitely this is the maximum volume. In this problem, they have asked you about the maximum volume. So the answer that you have to provide is this number. but sometimes they ask you for the dimensions, yes, of the cylinder. So it means that you need to tell me R, you need to tell me height. R is given 5, you put it back into this formula. 75 divided by 5 is 25, is 15, minus 5, 10. So if I want to achieve that maximum value, I need to choose a cylinder whose radius is 5 and its height is 10. Yes? But this is...
Why did you take 5 cubed?
Pardon?
75 times 5 minus 5 cubed.
Oh.
That's
Thank you very much. I made a very
That's
stupid mistake. Thank you very much. I have to put it back. I put it wrongly in a mixture of these two.
Exactly.
Yes, sorry for that. Thank you for reminding me. I realized just right now because when I put those numbers, it didn't give up 350. So I'm very sorry. I have to put it in the function. Yes or no? That's the function.
250, I think.
Yes, so I have to put it here. So this becomes pi 75 times 5 minus 5 to the 3.
So that's 175.
That is 250 pi. Am I right? Yes, that is 125. Yeah, that's correct. Thank you very much. Okay, now let me just repeat myself. In this problem, they have asked about the maximum volume. So that is the answer that you have to provide for this problem. But they might have asked you about the dimensions of the cylinder with the highest volume. Then it means that they are asking about R and H. R is given, that's 5, because 5 gives rise to this maximum value. So the R should be 5. And then you need to find H by putting 5 here. 75 divided by 5 is 15 minus 10. So the height should be 10, the radius should be 5. If you want to maximize this cylinder, but you want to keep the area this number. Yes? Is that clear? Okay, so that was a good problem, actually, I would say. I see in the book they have done it with the sine table. That is also correct. I don't know why they have deviated from the standard way. So the standard way of finding the maximum and minimum needs a function, a continuous function, and an interval. But of course, they have done it in a different way. So they say that, okay, they say that this number 5, this is R, and this is V prime of R. So this is 5, and this is 0, and I don't know whatever this is. So they don't care about it that much. But when you put the derivative, when you put 5 in the derivative, you get 0. But before 5, they realize that this is increasing. So the derivative is positive, and then immediately after 5, this becomes increasing. You can put it here to convince yourself. Choose a number less than 5 and put it here, it becomes positive. Choose a number greater than 5 and put it here, the derivative becomes negative. So this means that this is increasing, this is decreasing. So that is a maximum. Yes? But I want you to understand, this is in its own is not enough. This tells you that is a local maximum. But why is it a global maximum? Of course, in this case, it is true because the endpoints touches the axis here, and then you have one local maximum. So the local maximum is automatically the global maximum. So that is not wrong. If you want to do it in that way, that's also correct. Is that clear? Yes or no? Okay. I would say that let me just do one more example and then I can leave you to work on the problems yourself. There is another problem. Let me do it here. Of course, there are many nice problems if you want to do optimization. And I really recommend you try to solve as many problems as you can for this section because this really needs practice, okay? Especially the first part. Because when you have the function, when you have the interval, I think that is easy. But reaching to that, you need to do some work. Okay, so I I don't know the good numbers, unfortunately, in my head, because otherwise I would face a little bit of problems. Okay, let us just with a random number. Okay, so let me make the numbers as friendly as possible. So assume that you have a cardboard in the form of a square of length 10. So let us make it 10 centimeters. So we have a cardboard of a square form in this dimension. I want to make a box out of it, an open box. So I mean that there is no lid on top of that, okay? So how? By cutting some squares, okay, of the same size, and fold these up. Yes? You can imagine, yes? So I cut it out, cut it out, cut it out, cut it out. Then I start folding them up. Yes, it gives me a box without any lids on it. Yes, is that clear? Now my question is that how much these little squares should be? What, for example, how should I do this cutting so that I have the maximum possible volume for my box? Which is also practical, yes? If you want to keep something in the box, you prefer the volume of the box be as much as possible with the material that you have in hand. So that's also an optimization problem. I have the same material in my hand, that is the cardboard in my hand. I want to cut it in an optimized way so that the volume, probably volume matters for me. Yes, not the very actual shape. What should be, how should I do that? By how should I do that, what do I mean? Assume that you really want to do it. So you need to know the dimensions of these cuts. Yes? So this means that my dimensions are not clear. So let me call it X. Yes? So then, of course, if I want to make a box, everything should be X here. But what is your, again, let us not confuse you. This is the problem. To solve the problem, you need a function. So you need, what is the target function here? It's better to call it V because it refers to the volume. So my question is that, how should I do this so that I will have a volume, a box with maximum volume? Okay, let me just repeat what I told you. The first step, you have to write a function for your target quantity. Your target quantity is the quantity that you want to optimize. In this problem, volume is the quantity that you want to optimize. So you need to write a formula for it. So can you tell me what is the volume of that box? Just imagine, if you cut it, can you imagine this becomes a rectangular box. And the volume of a rectangular box is the area of the base multiplied by the height. Yes or no?
Yes.
Okay. So assume that in your head. First of all, the height is very simple. Assume that I fold it up. What would be the height of my box?
X.
X. Is that understandable? Because this length is X. And when I fold it up, then this length becomes X. Yes? Okay. So the height is X. So I have to multiply by X at the end. That's the height. But can you tell me what would be the area of the base? What is the shape of the base first?
Square.
It's a square. So what should I do?
10 times 10.
No. 10 is the whole dimension before cut. When you fold it up, so do you agree that this would be the base of my square? Yes or no?
Sure.
Okay, what would be the dimension now?
10
Yes?
minus 2x.
10 minus 2x. Yes, because I have one x cut from here, one x cut from there. So the total length was 10. So it becomes 10 minus 2x. But the other one also becomes 10 minus 2x. So the area of the base becomes 10 minus 2x times 10 minus 2x or 10 minus 2x squared. So this is one of those problems you don't have any constraints. You have a constraint, but constraint is already implemented in that. You have a function. How many variables are involved?
One.
Just one. So you really don't need to do anything. So you just call it v of x. But in principle, you should also have an interval. But it is not hard. First of all, what is the lowest possible value for x? X is the size of these cuts. So x should be definitely greater than 0. But is there any maximum value for x?
Well, it can never reach 10 technically, so wouldn't it be?
Better than that. Yes, 10 is the really upper limit. But better than that. For example, can it be 7? No, be careful. Because if I have 7 from this, I should also have 7 from that. But the total length is 10. So it cannot be 7. So what's the maximum?
Greater than 5?
Yeah, at most barely touches 5. Yes, it cannot be 5. If I make it 5, I will not have a box. I will have 4 smaller squares in my hand. Yes, so I cannot touch 5. I have to go up to 5. Yes, and then the problem is very simple now. So you have your function, and then you have your interval, and you want to run maximize. So forget about everything. Just concentrate on this problem. So how can I differentiate this function? Because you haven't studied the product rule and the chain rule yet, there's only one way for you to do that. Square it, using the squaring rule, multiply it, and then differentiate. So this is, you have to do it. So v of x is equal to, this one squared is 100. 2 times the first one times the second one is how much? 40x, and then 4x squared. And then I have 1x at the end. So finally, my expanded function is 100x minus 40x squared, and then plus 4x cubed. And then the rest of it is just differentiations. So the derivative of this function is 100 minus 80x. Yeah, that is a very bad number now, I realize. Okay, so that's inevitable. We have to put it equal to 0, and that is, we have to solve it using ABC formula. Okay, so that is your derivative. So if you don't mind, let me factor some numbers out to make it simpler for the future. So everyone is divisible by 4. So if I take 4 out, it becomes 3x squared. This becomes minus 20x, and then it becomes 25. And actually, these are really not bad numbers. Anyway, so v prime of x equals to 0. So this means that that expression should be equal to 0, because 4 cannot be 0. And then I have to solve this quadratic equation using ABC formula, for example. If you want to use PQ, you have to divide by 3, which is actually really awful wrong. So I would use the ABC formula. So it becomes 20 plus or minus 20 squared is 400. And then minus 4 times that is 300. Oh, that's a good number. We're lucky, aren't we? Am I right? So, yes, I'm right. And that is just coincidentally 100. Sometimes you cannot get so lucky if you do something randomly. But 100 minus 300 is 100, and the square root of 100 is exactly 10, and then divided by 6. And then you get 2 numbers. So x becomes 5, and then x becomes 10 over 6, or 5 over 3. So that's also some kind of extreme. It depends up to you. I would recommend you not to choose 5, because 5 is already excluded. So not acceptable, this one. Yes, because it is outside the interval. And in any way, if you want to solve the problem completely, you have to consider these things. But these are not the numbers that you're worried about. Why? Because if I put v of 0, it is 0. If I calculate v of 5, that's also 0. And that's also understandable. If I take 0, of course, I have just one flat cardboard with volume 0. And if I cut it 5, then I have 4 pieces. There are no volumes. Yes.
Why did you not draw a circle around 5 over 3?
No, it depends to your idea. I don't know. You can cross it over and saying that it is not acceptable.
Is it?
What was your question? No, because this is not excluding 5. Yes, this is not including 5. So you can say that 5 is not in this interval, forget about it.
Okay.
But at the end, if you remember the previous lesson, you should also consider these endpoints.
Yeah.
And if the max or mean occurs at them, then we exclude them. That's up to you. I mean that you don't need to be very pedantic here. But the point is that the number that I was looking for is this one. Yes? So if you really want to calculate is this. You need to calculate V of 0, but you get 0. You need to calculate V of 5. You really get 0. And then you calculate V of 5 over 3. Then this means that I have to suffer a little bit. And no, not suffering. I can put it here. Yes? Instead of putting here. Because if you insist to put it here, you will get the same number, but I think it would be easier if I put it in the original form. So then it becomes 10 minus 2 times 5 over 3, which is 10 over 3, and then a square, and then multiplied by 5 over 3. Yes? And then what happens here, it's 20 over 3 squared, and then 5 over 3. So this is 20. 20 squared becomes 400 over 9 times 5 over 20. So this becomes 2000 over 27 volume units. So this is, of course, it is clear among these three numbers, that number is the maximum. So it means that if I want to make what is the maximum volume is that number, how can I achieve to that goal? By cutting 5 over 3 from each side. Yes? But of course, there is a very big practical problem. Can you say why? Because it is not possible to cut exactly 5 over 3 in practice. Of course, you can get closer to this, yes, because 5 over 3 is how much is 1 point something, etc., etc. So you can get closer and closer to that cut, but at least theoretically, it is possible. Yes, but you cannot achieve more than that volume. If you need more space, you need to pay money. Yes, but if that's enough for you, that's it. Okay, so that's optimization problems. Is that understandable? Okay, so I think that's a good point to stop here. If you have any questions, please let me know. Otherwise, I don't know how much is left for you. Yeah, you have enough time, I think, to practice. I will try to update the Google Classroom here. No questions? No? Okay, thank you, people at home joining me here. Thanks.